So I had a slight issue I had to come back and modify. So here where the outline, which is just marked on the silk screen, what gets printed on the board, uh, extended beyond the outline of the board, which is no problem when we order the files. Ordering the Gerber files from the factory, they would just stop printing at the side of the board. But I have a script set up in Blender to generate a 3D model of this that I find useful for inspecting. Makes it easier to inspect it before ordering it. And then it also makes it a lot easier to generate the case. I just go ahead and do all my CAD work in Blender to generate uh, the files for the 3D files for the case to send off to a factory, which we're going to look at in a moment. But that little extension caused a problem when I was trying to generate the 3D model from these files. So I had to come back in and adjust this, and figured I might as well show what I did. So whenever we have one of those images, we can get the footprint. If you go back to the library, and when you're in the library button, there's an edit option. So if you go to take that edit option, you get here, and then we can select sections of that footprint, and I've moved that extension up inside the board so that we could still tell where the USB is on the silk screen. And then I made a copy of everything and replaced that nano with the modified footprint that doesn't have the PCB sticking out beyond it. And while I was at it, I went ahead and straightened up a couple of these lines to make them more parallel. And now, in order to paste that in, I had to cut all of the connections. So I need to reset up all that connection information. And remember, at first we just did it with a line, but over here at the other end of that connection, or anywhere in the track, we still have the name. So I'm going to copy that and paste that onto this pad where it needs to connect. And same thing on each one. So go to that track, copy the network connection, what the computer is actually keeping track of, and paste that in as being part of the pad. So now, if I grab one of these and bring that end away, you can see it reformed the connection. Because like we saw in an earlier video, the connection is internal data. So you have to make sure and reform the connections if you do something like that. So I'm going to go ahead and reform all these connections and then download the Gerber files again. Okay, so I think I got all this corrected, but to check, I like to grab the little endpoint and drag it away and make sure all those connections are still there for all the pads. It happens sometimes. Little issues show up and might have to make modifications. So this is one network, so I can just drag that over there. Yep. And just make sure that there is still a connection going to every pad, because that will be very important. Otherwise, when the machine prints that out, it wouldn't. Yeah, that's how the machine knows where to make connections. So we can just unhook the track and see the connection line there. Okay, that one's still there. Yep, so it looks like those are all good. And the silk screen doesn't extend beyond the edge now, so it's not going to throw off 3D modeling software because it doesn't know what a silk screen is. It's just generating things from those layers. So now we can generate the Gerber files again. Oh, I like software that auto saves. I've become quite spoiled by auto saving over the years. So now generate the Gerber files. Nothing changed in the price, and we can see there's nothing on the files extend beyond there. So I'm going to go ahead and download this and then go through all the inspection process that I have set up in order to make sure everything's in track, and then, like I said, generate a 3D model, because I find that a whole lot easier to inspect than a 2D image. So I'll go get set up for that. The software that I have, well, we'll talk about that in a second. So So let's go get set up for that. But do have to make a slight modification because I'm only 2/3 of the way done with automating the process of generating my own inspector and the 3D model. So still have to do the first step, but then the second step, the other two steps are fully automated. So let's go look at that. So the software I've been building up for these projects have a small script that will generate HTML code from those Gerber files. Well, we have to make a change. We have to open the Gerber files and export it to an SVG, each layer to an SVG file, because I haven't got the automation on that part done yet. And then once I have that, I have this thing on my GitHub with that'll generate a viewer on the web page in HTML format, so we can put that into our documentation for the project, and a plugin for Blender, 3D modeling software that will just make a 3D model of that circuit board, everything sized exactly, and that will, and I just do all of my CAD work in Blender to get it ready for the case and everything and put all the projects together. We'll see that in a moment, but I have the generate the HTML part and generate the 3D model, but I haven't done the first, there's still one more step to automate that I haven't got yet, but I'll include the link to the GitHub here, and I have that, both of those downloaded. So I'll start with the Gerber files here. I'll just copy those and move them over to the project. I'll make a new folder here called circuitry. Circuit works. I'll call it circuit. Go in here, paste this, and then extract all those files. And in order to use my those scripts I have set up, I initially have to open it in another viewer, which this is essentially what we're making to add into our web page documentation. But I haven't done the first step of export of converting Gerber files to SVG files. So I have to go in some other software and do that manually, which is fairly straightforward. This is something to view that, which is very useful for examining your design. You want to go over it in great detail, go over the circuit board, the printed circuit board design in great detail in something that does not have edit capabilities. Because it's really easy to make a mistake if you try to examine it in the same place you edit it. So this is just a place to look at that image without being able to edit it, which can be quite useful. So just go in here. So a bunch of Gerber files for the machine to run to produce the PCB, and then a text file on how to order it. So we need everything except that how to order. Open those. I'll maximize this. And yeah, we'll put one of these in the web page where we can turn off the layers one by one. And then we'll also generate a 3D model from these files, but I haven't automated the first step yet. So I do have to manually come through here and export every layer. So come to turn most of them off, come up here and export this. Go in circuit, create a new folder called SVG, and then I will call this board outline.svg. And now I'll come back and turn on each layer one at a time. And the plugin I created for Blender uses the board outline to line everything up. So each layer has to turn on each layer with the board outline after that. So I'm going to go through and do those, because then it's just turn the layers on one at a time, come up here and export it to the right folder where I'm at now, bottom layer. So then bottom layer.svg. So it's just that step over and over again. There's no need to watch me do that. So I'll go ahead and pause the video while I export those files. And then the next two steps are automated from this. And this one will be automated soon and on that link on GitHub. And here's the part that I haven't automated in this yet. Just have to set up a folder with each layer from the Gerber files converted into an SVG file, and then this a text file with the names of all those SVG files in the names of every file in the folder, and then this Python script, which I'll just edit with idle here. So that is obviously a whole lot easier to automate than the parts that have been automated. I did the hard part first and haven't got back to the other one yet. But just convert instructions for a machine to draw lines, to print lines, into SVG files for the computer to draw lines to show on a screen. A very easy conversion to create all those, and then the file names is just generate that text file, and then, well, generate a text file with a .py extension to get this script included in there. And this script, is this the script I want? Oh, this is not the script I want. That is the generate the 3D model script. So that's not the script I want. So close that. And it's on that, in that folder from that's on GitHub. I want PCB viewer for web page. I want this script, which again is really easy to automate. Just during all that automation process, just go ahead and type up this file with a .py extension, and then somewhere just go ahead and run it. And all this does is it looks at that text file of the file names, reads through them, and converts the SVG into HTML code and outputs an HTML thing. So if I run that real quick, apparently got a typo in the name. This file should have been board outline, not outling. So let's try that again. Board outline.svg, which that is something that obviously wouldn't be a problem at all if this was automated. So come back over, try running that script again. That time it ran, and we have this new HTML file here called PCB. If we open this, you can see we get a regular 2D inspector view with some zoom in and zoom out buttons that we can embed in a thing, turn our layers off one at a time, examine them more closely, like turn off the words and the solders, and just turn on a few things like our bottom layer and top layer, and actually check the traces and all that important stuff. And then this I set up to embed right into the documentation for the project. So along with that, these same files will be used to generate a 3D model in Blender, which I'll use to do all the CAD work of design and get the product ready to order from a factory. And I find it a whole lot easier to inspect a 3D virtual model than the 2D images myself. We can see everything and go through it carefully here. The big point is, if you're going to inspect the image, you can do that in easy EDA, but it can be a bad idea to inspect the circuit someplace where you have edit abilities. So do the inspection where you can't accidentally edit a mistake in. So let's go over and look at the other inspector thing, the file for Gerber. So I'll go ahead and open Blender, and then we'll run that. So here I'm in Blender, and with those, after those SVG files are set up, which will be automated soon and on that same spot in GitHub, which the link will be in the description for the video where I'm talking about that. And here in mine, I'll set it to Control Shift left click to run that script. Control Shift left click, and now just navigate to that folder of all the SVG files and import. and it should just take a second and it will generate those. Well, it takes a moment. There it is. So you can see we have a 3D model and, well, two models. This one is an entire thing to use in the CAD design. We'll see that in a moment. So the drill holes, and we can build all our 3D cases. And then this model over here is set with the layers. So we can turn layers on and off as needed. So like the silk screen, you can turn that on and off, turn the words on and off, or turn the board outline off, and then view just the traces in there and go through and inspect it very, very thoroughly. I find that a whole lot easier to get the inspections done than the 2D image. And doing so, just made a copy of that and combined it all into one model for that's all one piece, like the PCB will come for generating the CAD files for a plastic case to put it in, and seeing how the finished product's going to look. For example, let me open another Blender file here real quick. So for example, here's the files for a tactile momentary switch downloaded from the manufacturer. So, whoops, I don't mean to measure that. I want to select that. So if I select the pieces here, or at least the important pieces here, and hit Control C to copy, then come back over here and Control V to paste, you can see everything's kind of positioned the right size. So this needs whoops, wrong object. So I'll select those and just kind of move them around. Well, it needs rotated, so grab this, rotate, something like that. But, well, a little bit off, just in a hurry here, but you can see the holes line up. It lines up so I can build a CAD model of the circuit and use that when putting the case together. Very useful thing. And, whoops, thought I had the shift key held down. Shift drag, and then have this one over here where I can turn the layers on and off and get a very thorough inspection on a 3D model, not a 2D image. So we'll come back to that. For now, let's go put the 2D viewer that we set up in the web page documentation for the project. So here we are back over in the HTML for the schematics page of the documentation, and I went ahead and opened that PCB.html file that we generated. So you can see it brought in all those SVG files, quite a bit there. Be a bit much to type that. So we just need to embed this HTML page into this schematics page, and we can do that with just a simple iframe. So after the schematic object, holding the PDF, you can come down and let's see, I'll put in another header, PCB, oops, H3, and then stick in an iframe with the source equal PCB.html with, I'll make it the same size as these others, so 900 or 700 by 450. I'll try 900. That can be adjusted later, obviously. Just getting the first draft together so we don't get, so it doesn't get behind on us. By 750, so that a word, well, not 750, by 400. Just a nice little square. Let's maybe 500. Just guessing the number there. So I'll get our iframe in the iframe, and that should add that to our page. So if I take and copy that PCB.html over to the documentation folder and go back in here on the schematics page. Did I save that? I'm not sure if I saved that. Oh, yep, apparently did. So here's our little viewer. It probably could be a little bit taller or wider because that doesn't quite seem to fit there. But we can zoom in and out. Where'd the Notepad++ go? Let's make it 1,000 by 700. See what that size looks like. There we go. So now you can see we have a viewer that we can use. Might as well do it down here and kind of go through and examine the board carefully with examine all our connections carefully in either 2D or a 3D version. So I'll go through and do all those checks, and then I guess the next step is to actually place that order. And while we're waiting on it to come from the factory, we can start doing the scripts that will run on the PC and receive the commands from the controller.